This video explains a little about the relationship between measurements of atmospheric pressure and the altitude at which those measurements are taken. We know that atmospheric pressure is lower the higher we go above the Earth's surface. So what we would like to be able to do is work out what height the CanSat is at when it takes different pressure readings. So to have a look at that, I'm going to go back and look at our original pressure program and then see how we can adapt those pressure readings into altitude readings. The word altitude can have different meanings depending on the context in which you're talking. So weather forecasters, when they talk about altitude, they generally mean height above sea level. In the aviation world, altitude can sometimes mean the height above an airstrip or a landing field. So when we're working with altitude on CanSat, we need to be clear which we mean. Now, it doesn't actually matter which you use, but just know what you're dealing with. Are you talking about height above sea level or height above the launch pad? The basic pressure sensor program that we've already written uses the CanSat to get measurements in millibars of pressure. So the next step is to take that data, maybe into Excel, and figure out how do we convert those pressure readings into altitude readings. And we'll need to do a few practical measurements to verify that our readings are correct. So to verify that the pressure sensor and the program are working properly, I took the CanSat on my laptop out to take some altitude and pressure measurements. So I went to 4 locations. I set up the laptop and the CanSat at the beach, which is at sea level, and then at 4 successive locations at higher altitudes. So at each location, I took the CanSat and the laptop out of the car, and I waited for a little while to let the temperature of the temperature in the box where the CanSat was to stabilize, and then I took some readings and I logged them to a data file using CoolTerm and saved them. Then in my notebook I took a note of where we were, and I'd also needed to know what the actual altitude at that site is. So to do that, I used a little app on my phone called Altitude, which really uses maps and GPS altitude information to establish where we are. There's several different methods you can use for that, but you do need to have some other reference that we can compare our calculations with. So here's the combined temperature pressure program. Now if I upload that to my CanSat, and then we'll just have a quick look at the type of data that will come back from it. Open the serial window, and you can see that we're getting the voltage reading on the thermistor, our calculated temperature in degrees Celsius, and our pressure in millibars. So this is the data that we're going to go out and measure now and see how that can be converted to real altitude. The CanSat manual gives you one formula for converting pressure into altitude or altitude to pressure. So this formula here has pressure on the left, and it is giving it to you as a function of height or meters above sea level. So we could use that formula to convert our pressure readings into altitude, or we could use, here's a more complicated one that includes temperature in its estimations. So for my purposes, I'm going to use the simple one initially. So for my experiment, I took the CanSat and the laptop to 4 different locations. The first one was at the beach, or 0 meters above sea level. The second one was at a local tennis club, which was 16 meters above sea level, and I got that from my phone's little app. The third location was halfway up a local hill, nearly 40 meters above sea level, and the final location was 80 meters above sea level. So I took readings and logged them to a data file on each of those 4 locations. When I returned from my travels, I had 4 data files on my laptop, each one recording data from a different location. In my notebook, I had a list of the locations and their altitudes. So now I've returned to the lab with my data in the data files, and I'm going to use Excel to analyze that information. So I've opened Excel here, and I need to import my data files. To do that, I open a new Excel spreadsheet, and I click on the Data tab here, and then I tell it I'm going to get it from a text file. Okay. Click on that and find the file. So that's the one from the first location. So I'm going to click Import, and then Excel gives me options about how it will identify what data matters here. So I'm going to tell it to start importing from row 1. Click next. It looks like it's divided up the data fields properly here. So I'll go next again. This all looks okay as well. So I'll hit finish. Then I'm going to start my data. It's asking me where I'd like to start. I'll start on this cell here, so I'll have room above the top for column headings and down the side for row headings if I want to put them in. Click OK, and there's my data. Now I'm going to save that, give the file a name and save it. After I enter the data from my first location, I'm going to repeat that process and bring in the data from the other 4 locations, just cutting and pasting them at the end of the file until all the data is ready. I now have all the data from my 4 locations in my file here. So I'm going to tidy this up a little bit. First of all, I think I'll get rid of this title here, pressure. So I'll just highlight that, press delete. And I might put a title on this one. So this is the thermistor voltage. And we'll just say that it's in volts. And we might widen that column a little bit. So I'll just click here, bring it over a little bit like that. Should be voltage. And we can delete all this stuff here. Just generally, the less clutter you have, the easier it is to work with things. So this is temperature in degrees Celsius. And this is our pressure in millibars. And again, I'll get rid of this row of data here. So we have pressure here. Next step is to convert it to altitude. So we need to go back and look at that formula that we had for relating altitude to pressure. This one here. Now I want to juggle that around so it gives me H in terms of pressure rather than the other way. So when I do the maths on that, we end up with a formula like this. Okay? So we can see that H is a function of pressure. Now I would like Excel to do all this work for me. So we'll go back into Excel and see what we can do there. Here's the data that we've just uploaded from the data files. And here I've done the calculations. So this is our formula, converting pressure into altitude. And what I've done is taken it step by step here. So the first cell here is just the pressure converted to pascals, which are actually the SI unit. Okay, and that's by multiplying by 100. So what I've entered here is equals G3 multiplied by 100 because the data is in cell G3. Then in the next cell, I took that and divided it by 101325. So in this cell I entered equals I3 divided by that. Next cell we got the log. If you keep an eye on what's up here, you'll see the formula that's in the cell. Next cell we divided that by 0.525588. Then 10 to the power of it, minus 1, and divide it by here. So in the last column we have the altitude values. So I've taken the pressure, applied the formula, and got the answer H. So this is H, or altitude values, for all of the data. Once you're the first row done, if you right click on the cell, you can stretch down and copy the formula right down to all the other cells. Now let's plot a graph of this and see what we've got. So I'm going to highlight our altitude values all the way down there and hit insert, scatter graph, and we'll go with this one. Okay, so now I've got a rough graph of what we've got. So let's see. So here's our altitude over here, and these are just the sample numbers. So we've got more or less 4 distinct levels, which would make sense with the 4 different locations that we went from. Okay, so the lowest one, the next one, and the one at the top of the hill. There are a few little blips in the data, but you can expect that that will always happen. Now, the absolute altitude reading though is wrong, because certainly when I was at the beach I wasn't minus 260 meters below sea level. So we may need to make, well, we do need to make an adjustment to our calculations for that. So to do that, I'm going to come back up here and I'm going to have a new column which I will head up, call it above sea level. Okay. And all I'm going to do here is just add an offset. So we'll say that's equal to what's in cell 03 plus 271.633 in my case. Okay, so to make that 0 reading. Now it's showing as a very tiny reading there because of the format. So I'm just going to reduce the number of decimal places and change it from scientific format to general, to number actually, it'll work better. Okay. Now we'll extend that formula on down across all the cells. To there. Now let's try graph this second version. Okay, and see if that makes more sense. So again, I go up to insert, scatter graph, and graph. And here's our new one. Okay, let's just get rid of this old one so it's not confusing us. Just pull it down there. So now we have our altitude readings, and now they're making more sense. Okay, so our first one is here at 0 meters above sea level, which was at the beach. Second one, if you go back and check, was at the tennis club, which was 16 meters above sea level, which is about right. Our next one should be at about 36, and it is, and the last one should be at about 80. So having done that, I'm fairly confident that the CanSat is measuring pressure correctly and that our altitude measurements are correct. So having done that, it's also important to keep in mind that the atmospheric pressure will vary with weather conditions as well as with altitude. So it's probably a good idea on the day you're taking your measurements to take one reference measurement first, and also to keep in mind whether your reference is at sea level or at ground level, and subsequently your results are measurements of altitude above sea level or altitude above the height of the launch site.